Hello, hello. Um, hello, hello, hello. Let me get ready. You guys have the notes? Okay. Yeah, it is. So today's lesson is going to be two parts. One, we're going to finish the notes, probably within half an hour. And then we're going to play a little bit of Kahoot and see your faces one more time through Zoom. And that's it. All right. So that's what I have prepared for you guys. Hopefully you guys like it. Enjoy our last time together. All right. No, it won't be Mr. Quote Kahoot. It will be like a review Kahoot type of thing. Okay? Anyway, so today we're just gonna get started, okay? So we're gonna do we're gonna explore volume and surface area of spheres. Okay? The point is that you get to learn one more time before we say goodbye. You know, I might not be with you, but in the future, at least, you know, my legacy stays, right? So you gotta learn geometry. All right. So here's a sphere. A sphere is essentially a 3D circle, right? We call the center of the sphere center of the center, and it's the locus, which is all the points that forms the sphere, is made by equal distance from the center to whatever it is. So you still get a radius, just like circles, okay? And the top part, bottom part, these parts, half parts of circle, we call it a hemisphere, which is half a sphere, okay? Great circles, we briefly talked about this before, is like it's like a lines on the circle, and the great circle always divide the sphere into two hemispheres. Okay, so that's the first part. Now we look at the volume. They say the volume of a sphere with the radius r is v equals 4/3 pi r cubed. Now, why is that? I'm gonna send you a separate email on the graphic animated proof for both of the surface area and volume today for a sphere, probably sometime today. I'm going to send it over so that you can look at how these proof make sense. But I'm going to briefly talk about it. So here's a sphere, okay? Here's the hemisphere. This hemisphere is radius is r. Obviously, because the height is here, the radius is also here, right? R. Because this is r is the same as h. So when you open this and project this on the side, you're gonna get a cylinder. So essentially what I'm doing is I'm gonna open this sphere up. So what was here is now spread out into the side, and we'll make this part, which is basically a cylinder, and you digged out a cone out of it. Okay, so how do I calculate the volume of this? Isn't the volume of this the cylinder minus the cone, right? So a cylinder will be what? Pi r square h, but h right now is the same as r, so pi r cubed basically, minus, this is 1/3 of that, right? So 1/3 pi r square h, which is also r. So if you subtract this out, this is a like term, right? So it would be equal to 2/3 pi r cubed. However, we're only looking at a hemisphere, right? If we want a whole sphere, then we have to double this, times 2. Therefore, if you times 2, you're going to get 4/3 instead. Okay, that's the brief explanation on the projection proof that I'm going to send you today later. On the actual animation, you can see how it's projected, and you can see how it would make sense. Okay, so there's that. 4/3 pi r cubed. Now we're going to use it. Find the volume of a sphere. Give your answers in terms of pi. So you just apply the formula, but you have to first find out what r is. 4/3 pi r cubed, diameter is 24, so r is 12 inches, right? So the volume is 4/3 pi r cubed, which end up being what? I think it's like 2,000 something. 2304 pi inches cubed. Notice that we're doing volume, so we're doing cube as well. Okay. Try the right side. Try the right side. This is half a sphere, right? Hemisphere. Try the right side. I think Vidya is right here. Jeremiah, I think you did the whole sphere relative to half the sphere, hemisphere. Right, because this is half. 4/3 is the whole thing. This is only hemisphere, half. So you gotta do just 2/3 pi r cubed, right? If you multiply out the pi, I think it's 7,000 something. You're right, Samuel. 2/3 pi 15 cubed, which is going to be 2250 pi inches cubed. Okay, inches cubed. All right, example 2. Find the radius of a sphere with the volume. Doesn't this look kind of familiar? We just did this one. So, but normal circumstances, we usually, what we did was, okay, this is a sphere, so I know it's 4/3 pi r cubed. Right, and I know that the answer is supposed to be this. Right, so you gotta solve for r then. So we wanna first of all solve for r, which is here. So first of all, you can divide by pi both sides, so pi can cancel. And then you multiply 4/3 over, right? So 3/4, right? So r cubed end up being 1728. So then you cube root of this, cube root, you'll get 12. Units is in feet, so feet. That makes sense? So it's like the opposite. Okay? Look at the right side. Calculate both of them. Or if there's anything else you could do, try this one. Okay? They want to know there are two different diameters. Notice this says diameter. Two different type of exercise balls. How many times as great is the volume of a jumbo ball as the volume of a standard ball? Okay, try this. Got anything? .69 is correct. So when you find both of them, right, volume 1 is going to be 4/3 pi r cubed is 11 cubed, right? Volume 2 is going to be 4/3 pi r, which is 17 cubed, right? So you want the ratio between them. Obviously, you can calculate both of them out, right? If you calculate both of them out, you're going to get two answers, like how Jeremiah did, and then you can divide them. You get 3.69, right? So if you calculate this out and you calculate this out, I think I'll take Jeremiah's answer as answers. That's how much faith I had in him, right? And after you get that, you would divide this over that, right? And the answer would be about 3.69 times, right? We can also look at it at an alternative way, is that you know how radius is 11 to 17, right? That's the radius ratio. Because of that, think about what you need to do for volume. Don't you have 4/3 pi r cubed for both? 4/3 pi part is the same, so we don't have to look at that. The only difference is going to be 11 cubed versus 17 cubed then, right? So all you need to do is put 17 cubed over 11 cubed, whatever that is, will be your answer, okay? That's also the same idea as, you know, when we did similar polygons, the area is going to be squared ratio versus the scale factor of the length. Like if your scale factor is 1 to 2, then your area will be 1 to 4, right? This is because area is 2-dimensional. Here we're doing volume. Volume is 3-dimensional, so it will be cubed. Okay, that's the idea. Does that make sense? How are we doing on volume of sphere? 1 to 10. Can I have a comfort level? Got a 9 here. Good. All right, so let's go to the next page then. So that's the volume. Now we're looking at surface area. So this is surface area of a sphere is 4 pi r squared. Notice that it's 2-dimensional, so it's r squared instead of r cubed. Why is it 4 pi r squared? Later on, I'm going to send the same link to you in the same email on the animated proof. But basically, what they're doing is they're using these pyramids, okay? And then they're adding all the, they're going to go around and fill up the whole sphere, and then they use the base area to calculate the sum of the whole base area around the circle, I mean, not around the sphere, and then they'll get this conclusion. I'm not gonna talk about it for too long because I think it's the animation will make more sense. Okay, I'll send you the link. All right. Okay, so let's look at how to apply it then. So find the surface area of a sphere with a great circle that has an area of 49 pi miles square. So the area here, great circle, is 49 pi. Then what is the radius then? What would be the radius? Well, this is the area of a circle, right? Circle is 49 pi miles square, so it'll be r square, pi r square, right? So r is 7. If r is 7, right, then you want to find the surface area. Surface area is 4 pi r square, so that's going to be 4 pi 7 square, which is going to be, what? 196 pi miles square. Okay, make sense? Right side, same thing. You find your radius first. Diameter is 50, radius is 25, right? Same thing, not too hard, right? SA equals 4 pi r square equals 4 pi r square, which is what? 2,500 pi centimeters square. We're okay? Now, obviously, the challenge part is once again gonna be the composite figure that we have. Oh, are we okay with 2,500 pi? We're good, right? Okay. The last one is this. So, why don't I give you 2 minutes and you work on this? You want to find not just the surface area, but also the volume. You can do it in any order, okay? And then tell me the volume and surface area together, okay? So I'll do the volume first, and then do the surface area. But you can do it in any order. Okay. I might need more room. Maybe I'll move it higher. I'll put the volume over here. So the hemisphere, usually if it's by itself, then it's half, so 2 pi r squared plus a base, but now the base is covered, right? So you don't have to calculate this base right here. Okay. Since we're here, I'm gonna take this chance to take your attendance. So if you're here, just say you're here. All right. So volume, right? Volume, you just add the two parts together. So the top part is half a hemisphere, so it's 2/3 pi r cubed instead of 4/3 because it's half. Plus the cylinder, which is pi r squared h, right? Pi r squared h. Okay. Base area times height. Okay. And then you just calculate, right? So 2/3 pi, 2/3 pi r is 6, right? 6. 6 cubed plus pi 6 square times h is 9. I think this is 144 pi plus 324 pi. So together is 468 pi inches cubed. All right, cubic inches. Is that okay? Now your SA is going to be half of that, right? So 2 pi r squared instead of 4 pi r squared. The base here is covered, so you don't have to look at it. Then the next part is the bottom base. The bottom base is still there, so it's pi r squared. Right? The bottom base is pi r squared. Remember, how do you get the lateral area? Isn't it circumference times height? Because when you unfold it, it's going to be a rectangle with circumference as base. So you're going to get plus 2 pi rh. Okay, 2 pi r is the circumference times height. Okay, so together get 2 pi times 6 squared plus pi 6 squared plus 2 pi 6, 9. Okay, calculate it out. We get 72 pi plus 36 pi plus 108 pi. Together, 216 pi square inches. Is that right? You get the same answer? 452. Cohen, did you, huh? What happened? I mean, your answer is still a little small, I think. Did you do like, did you add the base? Did you add this base? There's a base in the bottom. Right? So I calculated the top hemisphere. Here, let me draw it for you. This is the surface area of the top hemisphere, right? And then this part is the base, and this is the lateral area, right? So 3 parts: the hemisphere, the base, and the lateral. Is that okay? Two pi rh. Oh. But is that the right answer? Okay. Anyone else got a different answer? Do you get the same answer? Are we good? Any questions? Okay. So, if you are okay, check your loop mail. I already sent your sent the Zoom link over. You can join there. I'm gonna open up the Kahoot, right? Once you join the Zoom, I'll share the screen on. You can see it, okay? And I'm going to close the link here. All right, so I'll see you in Zoom. Goodbye.